Alright, so in this video, I'm going to be solving the equation 8 to the power of x is equal to 80. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. I'm going to rewrite my equation here. 8 to the power of x is equal to 80. And now, my first step to solving this problem is rewriting 80 as 8 times 10. So now I get 8 to the power of x is equal to 8 times 10. And now I can go ahead and divide both sides by 8. So then these two cancel out, and I get 8 to the power of x over 8 is equal to, all that's left here is 10. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So a to the power of x over 8, well, 8 is the same thing as a to the power of 1. And a to the power of x over a to the power of 1, by using this property, is going to equal a to the power of x minus 1. And this is equal to 10. Now from here, I'm going to take the log on both sides. So I get log of 8 to the power of x minus 1 is equal to log of 10. And the reason I take the log on both sides is because now I can use the property that states that if I have something in the form log a to the power of b, I can move this exponent b to the front, so it's going to equal b times log a. So log a to the power of x minus 1, I can move x minus 1 to the front, and I get x minus 1 times log 8 is equal to log 10. And this property is really important because before, x was an exponent, and it's really hard to solve an exponential equation, but now we moved x, and now it's a real term, and it's much simpler to solve. So now what I'm going to do is distribute my log x here. So now I get x times log x, or log 8, which is equal to x times log 8, minus 1 times log 8, which is just log 8, is equal to log 10. And now I'm going to add log 8 on both sides. So then these two cancel out, and I get x times log 8 is equal to log 10 plus log 8. And now we want to isolate x. So what I'm going to do is get rid of this log 8 by dividing both sides by log 8. So then these two cancel out, and I'll be left with x is equal to log 10 plus log 8 over log 8. Now log 10, that's equal to 1, if you guys already know. So I get x is equal to 1 plus log 8 over log 8. Now, this is the same thing as 1 over log 8 plus log 8 over log 8. And log 8, these two cancel out, so I'm left with x is equal to 1 over log 8 plus 1. And log 8 is equal to 0.9031. So I get x is equal to 1 over 0.9031 plus 1. And 1 over 0.9031 is equal to 1.1073, and this plus 1 is equal to 2.1073. So this is my answer. Alright, so in this problem, I have 2 to the power of x is equal to 5 to the power of x plus 7. So, I actually have 2 methods to solve this problem. So make sure to stick around for the video to see me solve both methods. So for my first method, method 1, I'm going to write my problem right here. 2 to the power of x is equal to 5 to the power of x plus 7. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 5 to the power of x plus 7, I can write that as 5 to the power of x times 5 to the power of 7. And now from here, I'm going to divide both sides by 5 to the power of x. So then these two cancel out, and I get 2 to the power of x over 5 to the power of x is equal to 5 to the power of 7. Now from here, an important property of exponents is that if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 2 to the power of x over 5 to the power of x is equal to 2 over 5. And another property is that if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 2 over 5 to the power of x. And this is equal to 5 to the power of 7. Now from here, I'm going to take the log on both sides. So I get log 2 over 5 to the power of x is equal to log 5 to the power of 7. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so I get b times log a. In this case, I have log 2 over 5 to the power of x, so I can move x to the front, and I have log 5 to the power of 7, so I can move 7 to the front. So I get x times log 2 over 5 is equal to 7 times log 5. Now from here, we obviously want to find the value of x, so to do that, we have to get rid of log 2 over 5 by dividing both sides by log 2 over 5. So then these two cancel out, and I get x is equal to 7 times log 5 over log 2 over 5. And we have our answer here. This is our solution, but there is a way to simplify it more. So first off, if I have something in the form log a over b, this is equal to log a minus log b. So log 2 over 5, that's going to equal log 2 minus log 5. And now from here, I get 7 times log 5 over log 2 minus log 7 times log 5 over log 5. And these two cancel out, so I get 7 times log 5 over log 2 minus 7. And this is the same thing as 7 of log base 2 of 5 minus 7. Now for method 2, what I can do is, my equation was 2 to the power of x is equal to 5 to the power of x plus 7. And now I'm going to just start by taking the log on both sides. So I get log 2 to the power of x is equal to log 5 to the power of x plus 7. And now using that property, I get x times log 2 is equal to x plus 7 times log 5. And now if I distribute the log 5, I get x times log 2 is equal to x times log 5 plus 7 times log 5. Now if I subtract x times log 5 on both sides, these two cancel out and I get x times log 2 minus x times log 5 is equal to 7 times log 5. Now I can factor out x, so I get x times log 2 minus log 5 is equal to 7 times log 5. And divide log 2 minus log 5 on both sides. So these two cancel out and I get x is equal to 7 times log 5 over log 2 minus log 5, which again simplifies to this. So x equals 7 times log base 2 of 5 minus 7 is my answer.